And now we will look into the second learning outcome, which is measures of central tendency. Under this learning outcome, we will actually focus on, of course, quantitative data and how do we do measurement of mean, mode, median of group and ungrouped data. And also later on, we will learn about standard deviation and variance for group and ungrouped data. So for this part, we will actually look at measure of standard tendency for ungrouped data. So as a summary, mean for ungrouped data is just sum of all the values over total number of values. Okay, this is an arithmetic mean, yeah. And the mode will be the highest frequency, meaning the data that has the highest frequency will be the mode, or data that repeats the most often will be the mode. And median, basically for ungrouped data, there are two cases where the total number of data is odd or the total number of data is even. We will look into this case in detail in the coming slides where I'll show you example. Okay, now we will look at a simple calculation of arithmetic mean. The college principal, Mr. Smith, collects data on the ages of mathematics teachers in Travers College, and his study yields the data below. So to determine the average age of mathematics teachers in Travers College, you simply add all this data. There are 7 data available here. So you add all the data, which will result to 245 divided by the number of data. And so therefore the average age of teachers here is 30. The mathematics teachers in Travers College is 35 years old. Besides arithmetic mean, there are also other means such as the weighted mean. So weighted mean, according to the example below, Jenny obtained the following grades in her 4 subjects for this semester. Calculate her grade point average. So you list all the 5 subjects, and then these are the units for each subject, as in the credit hours, and this is the grade. So therefore, in order to calculate the weighted mean, you simply multiply the grade with the unit, 90 times 1.5, and you add all the multiplication of the grade and the unit for each of it, 86 times 1.5 plus 88 times 1.8, and so on. Once you total up the total of multiplication of grade and unit, and then you divide it with the total number of units. So therefore your average, the average score for Jenny is 87.67. So this is called weighted mean. Next, we will look into how to calculate median. So median, by definition, is simply the middle value of the sample when the data is arranged in ascending order. Ascending means from lowest to the highest number. So for example, you have a data arranged 60 to 44. This is arranged in ascending order. Okay. And if you realize that the number of data here is 1, 2, 3, 4, 5, 6, 7. Therefore, and 7 is an odd number. So when your data is odd, it's very simple that you know that the number in the middle is actually the median. So therefore, there's 3 data on the left and there's 3 data on the right. So the middle number here is 30. So it's very clear. It is actually 30. So by definition, if your n is odd, you just n your median will be the data, which is n plus 1 over 2. So in this case, your n is 3, 6, 7. So 7 plus 1 is 8, divided by 2 is 4. So therefore, your fourth data, which is 30, 1, 2, 3, fourth data is 30, which is actually the median. And for second example, when your n is actually an even number, so your data will be an average of the middle 2 numbers. So for example, you see there's 3 data here and there's 3 data here. So the average of the middle 2 numbers is actually the median for this example 2. So by definition, it is actually n over 2 term plus n over 2 plus 1 term. So as simple as there are, this is an even number, 8. There are 8 number of data here, so 8 is an even number. So the median will be 8 over data number 8 over 2. So 8 over 2 is fourth data, and data number 8 over 2, 4 plus 1 is the fifth data. So it is the fourth and the fifth data for this sample, which is 1, 2, 3, 4 and 5th, which is 30 and 38. So the median will be the average of 30 plus 38 divided by 2. So next we will look at mode. So mode is simply the value which occurs most frequently in a set of measurements. So for example, if you have a scenario as below, the following are descriptive evaluations of 5 teachers. So 1, 2, 3, 4, 5. So the number of data is 5. You are expected to determine the mode for the scenario. So in this case, if you look at the letter VS, okay, is some descriptive evaluation. VS actually occurs 3 times out of the 5 number of data provided. So it's very clear VS is actually the mode for this set of data. So mode is simply just a data that occurs most frequently in a set of measurements. So now we have looked at ungrouped data just now. Now we will move on to group data. So group data is quite similar to ungrouped data, just that the formulas differ. So average of group data is simply sum of frequency multiplied by x. X simply here is the midpoint of each individual class, if it exists. Okay, and f is basically frequency of each individual class. So later we will look at an example which you can relate to the definition, and n is obviously sum of the frequencies, and mode is midpoint of the class with the highest frequency. So if it's a group data, most of the time it is by class as in like 100 to 110, 111 to 120 and so on. So normally you actually identify the class that has the highest frequency, and then you choose the midpoint being the mode of the data. And median, for median, this is the formula used for group data that has data grouped by class. Okay, so L here refers to lower limit of the median class. Okay, later I will show you an example how to actually identify the L. And CF is actually the cumulative frequency before the median class, and F is of course the frequency of the median class, and C is of course the class interval, as in it is 100 to 110, so there's 10 data, so therefore the class interval or the size of the class interval is actually 10. So now we'll look at an example which actually explains to you how do you actually get mean for a group data. So example, your class is given 130 to 140. This is just another method of writing a class. Okay, you can also write it 130-140. Okay, it depends. So in this case, the frequency is given. Okay, the midpoint is midpoint. How do you actually identify midpoint? Is the middle point here. So 130 to 140. How to get midpoint is you plus and divide by 2. So 140 plus 130, when you divide by 2, you get 135. Same goes for the rest. You just add and divide by 2, you actually get the midpoint. Next, what you do is you multiply the frequency with the midpoint, and that's called FIXI. You do it for each class. Once you do it for each class, and then you sum up the sum of the frequency multiplied by the midpoint. You need that value to calculate the mean. So the mean average of the, that means the average of the data is simply the sum of the frequency multiplied by the midpoint over the cumulative frequency or total data available, which is 62 in this case. And so the real mean for the raw data is actually 155.8548. Okay. Next, we will move on how to identify. It's the same set of data, how to actually identify median for this group data. So to find the median, this was the respective calculator formula. Okay, so we have to substitute it accordingly based on the table. So therefore, when you have group data, it's advisable for you to actually draw the table out as shown in this slide. Okay, so in this case, you have to have a table that shows the cumulative frequency so that it eases your calculation. So L is actually lower class. So in this case, your L here is actually 150 because it's the lower value of your median class. Okay, how do you actually know that median lies here? Okay, so you look at the total frequency and you divide it by 2. So by estimation, your median should lie in this class because your median will be 31, data number 31. So here there are 18 data 31 will lie in this class. Okay, so first thing, the lower boundary is actually 150. Okay, the class size is obviously 10. 160 minus 150 is 10. Okay, multiplied by n over 2. Okay, n over 2 here, obviously n is the total data, which is 62. So 62 over 2 minus this is the cumulative frequency before the median class. So it's obviously is 15. Okay, 15 and over 23. This 23 actually is the frequency of the median class, which is this. So you substitute it and then you calculate using your calculator. Please be careful to sub with the terms because some of it is cumulative frequency and some of it is just simply frequency. So you need to know the difference between frequency and cumulative frequency. Next, we will look at how to identify mode of a group data. To identify mode of a group data, you have to observe the data frequency. When you look at the data frequency, this is the same set of data for group data from just now that we have been calculating mean, median, and now is mode. If you study the data, the highest number of frequency is 23 and 23. So 23 is the frequency of the mode. Okay, and in the mode here will be obviously because this is given in a class, so this is the model class 150 to 160. So the midpoint of this model class will be actually the mode of the data. So the midpoint of this is obviously 150 plus 160 divided by 2, which is 155. So this will be the mode of the group data. And now we will look at what variance and standard deviation simply means to a spread of data. When the data elements are located nearer to the mean, that simply means it is less spread. This also concludes that the data is tightly clustered together and the variance and standard deviation will be small. On the other hand, when the data is spread apart, the variance and standard deviation is relatively large. So this data set will be far from the mean and will be considered to have a greater spread because it has larger variance and standard deviation. So when you need to calculate the variance and standard deviation for ungrouped data, these are the basic formulas given. So this simply means X is each data. Mu, I think you know for now, is actually mean, and N is the number of data. And this is an alternative formula for to calculate variance. And standard deviation is always the set of variance. So if you are able to calculate variance, then you can get standard deviation by square rooting the variance. For example, calculate the variance and standard deviation of the following two data sets. Hence, comment on the standard deviation obtained. So you have set A, you have set B, the mean of set A. Why we need to find mean first? Because if you looked at the previous the slide, the example has a mu. That symbol mu is actually mean, right? So you need to identify the mean first. So you identify mean of set A, mean of set B individually, and then next you calculate the standard deviations. So here you have set A and set B. As shown here, it's always advisable to actually do tables, because tables simplifies your calculation and also minimizes errors in statistics. So you have set A, you have set B. Okay, from there you can actually identify the variance, because variance is sigma of x minus mu square, which is for set A is this, over the total number of data, which is 7 data. And so the standard deviation here will be set of variance. So for set A, the variance is 2, the standard deviation is set 2. And for set B, again, sum of x minus mu square is 2792, and the total number of data is 7. So the variance for set B is larger, and of course it will contribute to a larger value of standard deviation, simply because standard deviation is set of variance. So but in comparison, set B actually has a larger standard deviation. So therefore um, it is actually located far from the standard deviation, sorry, far from the mean, and also more spread. Okay. Next, we will actually look into variance and standard deviation for group data. So this is the basic formula. So what is added here is actually M is for midpoint, mu is for mean, F is frequency. Yeah, okay, multiplied by how much the midpoint deviates from the mean, and over the sum of, or the total number of data. This is an alternative formula, whichever you would like to use, you're free to use. And standard deviation again is set of variance. So this is specifically for group data. So whatever has a F frequency is a group data. Yeah? Okay. So next slide, we will look at one example. Group data, obviously there's a class. Okay, and it's a number of days. So in this case, you construct a table. It makes your calculation easier. So for this part, I actually use the second formula. Okay, so the second formula, the alternative formula for variance, is actually sum of m squared times f. Okay, which is this. Take away the sum of mf square over sum of f. Okay, or the total number of data 50 over the total number of data, which is also 50. You use your calculator and you get this value, and the standard deviation is of course set of the variance, which is 9.689. So my advice to you is, when you want to calculate variance, standard deviation, especially for group data, it's advisable to actually draw the table out, because it minimizes error and it helps in your calculation and it helps you to be systematic.